We are ready for our next speakers. Again, thanks for joining us in the All Lines Technology Breakout Tech Talk session. Again, my name is Brant Gall with All Lines Technology. For those of you who aren't familiar with us, you can feel free to stop back at our table, gather a little bit more information. But with respect to time, I'm going to hand it directly over to our next presenters from RJ Lee Group. We have Duane Conley, Brian Zemba, and Anthony Storti.
Thank you. All right, hello, ladies and gentlemen. Oh, good. Can you hear me good there? Excellent. All right, as he mentioned, I'm Duane Conley, and just to touch on, you can see the titles of who's represented. I won't spend a lot of time on that. I am going to be double-handing it here, so excuse me if I do end up pressing the wrong button, but let me jump right into it. Many of you may be familiar with RJ Lee Group, but we are a material characterization company located over in Monroeville. What you may not be familiar with is that we do have a very strong software development organization. Listed here are some of the verticals that we touch. Along the bottom of the slide, you'll see some of the different software languages and capabilities that we have. Oh, I almost pushed the wrong button there. The focus of this presentation is going to be on a platform that we've developed over the past probably 6 years with the Air Force. And we are now commercializing it under the name of SEAMS, and I'm going to be touching on the capabilities of it. After I go through the capabilities, I'm going to be discussing 2 specific use cases and going through the benefits of those use cases. Now, SEAMS is an enabling technology for digital thread, digital engineering, Industry 4.0, Industrial Internet of Things, regardless of which catchphrase you may be using or you may be familiar with. SEAMS basically helps you on your digital transformation. And we do that as almost pushed the wrong button, by creating a more data-centric process and helping you organize your data, bring that data to the forefront to help you with decisions. Now, you may ask, what exactly is the Industrial Internet of Things and digital thread? I want to focus on the definition up top. Digital thread can provide an aggregated information map of an asset's life cycle and pull that information from siloed data sources. Now, the visual, I think, provides a better understanding of what I'm talking about. Look around the visual here. Across all of our environments, regardless if you're a manufacturing environment, a maintenance environment, an engineering environment, a financial environment. Basically, in all those environments, you have siloed data sources. I'm just giving a representation of a few here. What you need is an information broker of some type to help you have a holistic view of the data you have in your environment. And that holistic view then will aid you in decision support for whatever you're trying to do, whether it's acquisition, whether it's engineering decisions, whether it's social media type decisions, whatever you're trying to do inside of your organization, you need to have a holistic view to help you make those knowledgeable decisions. That's what we created SEAMS for in the Air Force, was to help them. You can imagine inside the Air Force the siloed databases they have. Now, how does SEAMS and the Internet of Things and digital thread kind of tie together? Again, I'm walking through an example here. This is a manufacturing floor example. Imagine on a manufacturing floor, you've got machinery. You've got engineering groups. You've got manufacturing groups. You've got legacy systems. These could be Oracle systems, SAP systems. These could be SQL database systems. All of that contains siloed data. They're information sources. You need those, again, to make decisions. Now, of course, your engineers, your analysts, your scientists, they can reach out to those and pull that information themselves, but that takes time. And that's what they're doing right now. That's what the environment looks like now. They're doing that manually. That's very inefficient. Now, a lot of people will say, I've invested millions in a PLM. I've got a PLM. PLMs are excellent at categorizing equipment. They're excellent at archiving equipment, or not equipment, asset information. We're not here to replace a PLM. PLMs are very good at what they do. To us, a PLM is another data source. Now, this is something I know the guys over here, they like me to go into a lot more detail here. I'm a very simple fellow. I like to break things down into general terms, and you can tell from my accent, I'm a Southern boy. So just like Matt this morning, he's an Alabama guy, I'm a Georgia boy. I like things very straightforward, very simple, easy to understand. So when I break this down, the first part up here, I like to call this 25% of what we do. Automatic indexing, crawling through the data. Crawling is an action verb. It basically means that our software crawls through automatically. It is doing it the entire time, and it doesn't miss anything in the data. Now, the second part down here, a lot of times I call that the secret sauce, the 75% of what we do. This is a machine learning type functionality. It creates links inside of your data so that your engineers aren't doing it. Picture how your engineers and your analysts are doing things right now. They're downloading data from different siloed databases. They're doing extracts of that data. A lot of times they're making notes in journals. They're dumping data into Excel files, and they're making a lot of manual notes. Again, that's very inefficient. It's very time sensitive, or not time sensitive, but it takes a lot of time to do that. It's very inefficient. Wow, I got to tell you, every time I see this slide, I think that is a massive amount of information on a slide, but it's there for a purpose. Every organization has a good bit of these systems represented in that organization. And each one of these systems are typically siloed systems. The data's not talking to each other. The data's not shared with each other. And your analysts and your engineers are having to pull information extracts from each one of these systems and then use that information to make decisions. Again, that leads to inefficiency and time those engineers are having to spend and those analysts are having to spend pulling that information. What we're looking at in the middle here, I like to call this the brain diagram. Picture each one of those dots as a piece of data. That knowledge map that I showed on the previous slide is creating systematically those lines or the linkages between the data. So now when you're doing discovery with the SEAMS tool, it's creating linkages. It already has systematically created linkages in the data so that now you're discovering additional data points that you weren't finding before. So instead of your engineer having to go out and pull information from different sources, the system is doing it for you. Now I'm going to get into the case studies. This is the real meat of the tool, or the meat of the presentation, and hopefully it's what some of you guys were coming to see. The first thing I'm going to talk about is the TDAS system, the Test Data Aggregation and Analytics System. This is the genesis of where SEAMS had its development, starting back in around the early 2012 timeframe down at Arnold Air Force Base in Tennessee. We developed the system to meet a need they had. All right. Let me touch on right here. Notice down here in the bottom, because of what we accomplished down there, we took the system all the way to its authority to operate. And it is now in production down at Arnold Air Force Base. They're using it down there. They were so pleased with what we did, they nominated us for a Success Award with the Small Business Program. The Small Business Program turned around and did a video success story on us, which is now on the Small Business website. So that can be looked up on the Air Force's Small Business website. On the right side of the slide is another program we did out of Wright-Patt Air Force Base entitled the Digital Threat Infrastructure for the Material Review Board. We worked with Pratt Whitney on this program. There was a sister program awarded at the same time with Northrop Grumman, and we both took different approaches. The goal of this program I'll touch on as well and show some of the results. I love this slide here. I've got it in there basically to show you a picture of some of the things that go on down at Arnold Air Force Base. That's actually a large airplane engine doing a test down at Arnold. And I just love seeing the flame come out of the back of it. I wanted to show you something cool that goes on down at Arnold. This is the stuff we get involved with and get to see down there. All right, the scope of the TDAS problem. Increase efficiencies and reduce cost at Arnold Air Force Base. Picture what goes on down there. Every weapon system inside of the Air Force, when I say weapon system, aircraft and missile system, as well as almost every aircraft the Navy has and missile system, goes through testing at Arnold Air Force Base, and it has since back in World War II. So they've got a massive archive of data dating back 50 years. And they want to take and continue using that data, because now when they put another weapon system on the wing of an aircraft, they have to retest that aircraft. They don't want to keep doing that. They want to look at their archive data. Right now, they've likened finding data inside of their archive to finding a needle inside of a haystack. And I can't imagine how big that haystack actually is. The scope of the solution we put together for them is it had to have a very high level of DoD security. That was a must. It had to keep track of the pedigree of the data. They had to know the authoritative source at all times. That's very important in industry as well. If you don't know the authoritative source, what good is the data? You have to be able to track that back. Metadata, I'm going to jump down a little bit here. Metadata viewer and editor. They wanted to be able to bulk metadata tag an entire project directory, not just individual files. They wanted to do files as well, but they wanted to do the entire project. This last one was very important to them. Since a lot of their data was old, maybe a decade old, they wanted to be able to transform it into a format that was usable for their current analytics. That was the overall scope of that solution. And again, that was the basis for where we're at with SEAMS. Now jump ahead to the current project that we finished, the digital thread infrastructure for the MRB. This is where we progressed what we did with TDAS, took it to more of a next generation, and this is where we partnered with Pratt & Whitney. This was looking at the material review board. The material review board is a process that every prime that works with the DoD goes through. Picture this. Let's say they're creating a gear for an engine that goes on a jet. As they're creating and forging that gear, if there's a defect in it, it has to go through the material review board to see if that defect is minor enough that it can still be used. Otherwise, it has to be thrown out, and they have to start from scratch. It's very expensive. They wanted to decrease the duration, frequency, and of course, expense associated with it. They also wanted to look at adding some additional analytics to it and decision support analytics. This was some additional complexity for the MRB project. They wanted to look at 4 data sources coming into it. These were 4 data sources behind the firewall at Pratt & Whitney. I can't go into what these data sources were. This is proprietary between us, Pratt & Whitney, and the Air Force. I also had to change the names of what the type of data coming out of the data sources were to make it more general. But we did have to transform data, doing that with them. We were able to bring in the data from these data sources, bring it into SEAMS, and for the first time within Pratt & Whitney, we showed them how that without logging into different systems, they were able to see data from a central location, see the data all merged together, and the engineers were able to document significant benefits and significant efficiencies by being able to log into one system, look at 4 different sources of data, have that data blended together, and run through their analytics without the engineers having to go search for it individually, extract the data, and then choose what data they wanted to have to put into analytics. These are some of the overall scope of the digital thread program with Pratt & Whitney. Basically, we expanded the crawler of our TDAS system. We added some more complexity to it. We expanded how we extracted information. And then, of course, we did some custom analytics. Those custom analytics were not able to be put into the SEAMS platform because they were proprietary between us and Pratt & Whitney. The overall case study conclusions of both of these case studies, and these are documented conclusions, was that data discovery efforts were reduced, which created overall engineering efficiencies. The program that we did with Pratt & Whitney was required by the Air Force to document their efficiencies, wrap a dollar value around that, and provide that back to the Air Force. That was the overall reporting requirement for that program. Let me jump down here due to time. Uncertainty quantification benefits. This is a terminology some of you may be aware of. It's coming up quite a bit right now for those that are familiar with data analytics. And you wonder, how can we affect the uncertainty quantification by dealing with data searches and by indexing data? Well, we were able to do this down at Arnold. We were able to do this at Pratt & Whitney, and they documented the results. The way we're able to do it is by feeding better qualified and a wider variety of data into the same analytics. They were able to document that we affected the result of those analytics. And they did this through their own internal studies at Pratt as well as down at Arnold. And then lastly, we're able to transform data into useful context to feed knowledgeable decisions. This slide here is a real quick breakdown of some of the features of SEAMS. Basically, I wanted to point out that you can publish information into SEAMS. So you may have disparate sources out there. You may have data being generated on desktops and laptops by your analysts, by your engineers, by different people, and you're not sure where to put it. SEAMS can act as a repository. It can also act as a funnel to push data up into your SAN. Discover, of course, I've already touched on. I do want to jump past this to get into a few features here. This slide here, I'm going to touch on this slide and the next slide. Just like Google, you can do Boolean searches across your search line. Now, unlike Google, we crawl through and index every bit of textual content in your data, whether it is structured, semi-structured, or unstructured data. Notice right here, dynamic search results. Dynamic is a key word there. We're all used to Google where you have to open one of your search files. Oh, gee, that's not what I wanted. Okay, you close it, you go back to your search results. You open the second one. Gee, that's not what I wanted. You have to serially go through each one of them. With dynamic search results, because of that knowledge mapping I talked about, all those data linkages, you now have keywords inside of every search result. So when you open that first search result, there's keywords in there, there's linkages. You can keep drilling in almost indefinitely because of those knowledge map results. That's a very important feature that our customers are seeing benefit from. Over on the right, you have inferred results. These are things that you were not specifically searching for. Let's say you searched on a widget. Well, it'll come back and tell you that that widget is associated with an airplane engine. Maybe that widget is associated with a car. Well, maybe that widget is called a gadget in another part of your organization. It'll bring back those inferred results over here on the right-hand side so that, again, you're seeing those inferred relationships that you weren't specifically searching on. Now, if you click on any one of those search criteria, you can look at the details behind it. You can look at things like what the renditions were. You can see that there was a raw data. You can see that the file was transformed into a specific version that allowed you to run your analytics. You can see what scripts were running against it. There's a very detailed script editor that allows you to, oops, I'm getting the cut. I have made it to the end. You guys survived. For additional Q&A, please talk to us outside, and we'll be happy to answer any additional questions you may have. Sorry for the speed talking. That's hard to do for a Southern boy.